Hi guys, today we're gonna look at um, part 2 of exercise 7.2 of class 12 integrals. And in part 1 we completed the questions till question 25. So today we're gonna look at um, questions 26 to 39, right? So let's start, and we're gonna start with question number 26, which is the 26th question is the integral of cosine root x over root x. I hope you can see this color, by the way. I'll just switch it. Yeah, dx. Right. So we know that the derivative here, it's gonna be a straight u sub or a t sub, whatever. And we know that the derivative of, well, root x is 1 over 2 root x. And in the denominator, we do have a root x. So what we're gonna do is we're gonna multiply and divide the function by 2 so we can get the 2 in the denominator. So I'm going to multiply outside the integral in the numerator. It's going to be a cos root x dx. You can skip this step in the exam and directly enter it into the question. I'm just doing it so you guys can understand better. Okay, then we'll let root x be u. That gives us 1 over 2 root x dx is du. And we can see that there's a 1 hidden right here. So there's a 1 over 2 root x dx in the question. So we can replace that by du, and of course cosine of root x becomes cosine of u. Now we're going to integrate in the u world. That's going to give us 2 times sine of u plus c. And now we're going to replace u with what we took u to be. So u was root x. And I believe that is the answer. Alright. So now moving on to the next question. Um, yeah, that's gonna be question number 27. Question number 27 reads, we have to integrate sine 2x, root sine 2x times cosine 2x with respect to x. Now for sine and cos, usually they are the integrals or derivatives of each other, disregarding the sign, of course. So we can um, think of a u sub easily when there is only a sine and a cos in the question. Right, so for this, we're gonna let what's inside the root again to be t. We know that the derivative of this will be, um, well, the derivative of sine of x is cosine of x, and then of course for sine 2 of x, we want to apply the chain rule and multiply it by 2. So we'll have 2 cos 2x dx is dt. And here in the question, we do have a cos 2x dx. So what we're going to do is we're going to multiply and divide by 2 again so that we'll have it as we want. And I'm going to divide by 2 outside because we need the 2 in the numerator inside. I'll write this down. You don't need to show the step particularly. Right. And now this part is my dt, right? And that is a root t. That becomes a root t, and that becomes dt. And now we're going to integrate in the t world. That's going to be t, and using the power rule, since this is a half power, we're going to increase the power by 1 and divide by the new power, which is going to be 3 over 2. So I'm just going to take the 2 to the numerator plus c. Now, of course, this 2 and that 2 cancel, and we replace the value of t. So sine of 2x to the power 3 over 2 over 3 plus c. That is our answer. All right, guys. Then we're gonna move on to question number 28, which reads, we have to integrate cosine of x root 1 plus sine x dx. Again, we see a sine function and a cosine function, and usually whatever you have inside the root, you want to take that as your new variable, so you can replace what's inside the root with a single letter like u or t, and that way we can express it easily. Here we have two values, so we don't know how to deal with the root, right? So I'm gonna let 1 plus sine x equals t. Then I'm gonna differentiate both sides. That's gonna give me cosine of x dx is dt. So the numerator here becomes dt, and the denominator, of course, is root, and then we took 1 plus sine x to be t. So that. And now just rearranging or rewriting what was written, and now applying the power rule in the t world. So add 1 to the power and divide by the new power, which is 1 half. So I'm just going to take the 2 numerator, and now we replace t with what we took t to be. This is a square root plus a c. Right. So question 28, that's the answer. All right, guys. Hopefully by now you're comfortable with the u substitution, so we can go a little faster. All right. The ninth question is cotangent of x times natural logarithm of sine x with respect to dx. Right. So here we don't see directly how we can apply a u sub, right? So because we know that the derivative of log of x is 1 over x, and we don't have anything in the denominator here, seemingly. But if we take all of this to be u, log sine of x, then what we get is when we differentiate with respect to log, we get 1 over sine x, and then of course by the chain rule we multiply by the derivative of sine of x. So that's going to be cosine of x. So that will give us cosine of x over sine of x, which is just cot over x, which we do have. So it's important you see this right away when you see this question. But if you don't, I'm just going to write it in terms of sine and cos, and hopefully that will make it easier. Right, then I'm going to let um, log of sine x equals t. Then we have 1 over sine x times cosine of x times dx is dt, and cosine of x sine of x dx is dt. And now, of course, since we converted the cotangent to cos and sine, we do have this and that, which will combine to make dt. But if we write this as cotangent x dx dt, then we do have it directly because of cotangent x and dx. So I'm just going to make the substitutions now. So the circled part becomes dt, and of course log of sine x becomes t. Now we're going to use the power rule. That's t squared over 2 plus c, because increase the power by 1 and divide by the new power. And this becomes log squared of sine x over 2 plus a c. Right, and that is the answer. All right, the 30th question now. Right, so the 30th question reads, we have to integrate sine of x upon 1 plus cosine of x with respect to x. Here too we have cos and sine directly, and in the denominator we have more than one term, so that's what we want to take as a new variable, so we can reduce it to one term so that it's easily it easily can be integrated, right? So I'm sorry for that. I'm gonna let 1 plus cosine of x equals t, then negative sine x dx becomes dt. And now, since we have a positive sine x dx, I'm just gonna take a negative, and then we have a dt over t, because that's what we took t to be. This minus sign gets kicked outside, and we have a t to the minus 1th power times dt. And now we're gonna use the standard integral for this, which is just log of mod t plus a c, right? And now we're gonna replace what we t with what we took t to be. That will lead to this answer, which I believe is correct. And yes, it is. All right, that's done. Now for the 31st question. These questions are pretty straightforward, and you should be able to do them now that you know how to use a usub. So yeah, that is the question. And again, we have a sine and cos, and in the denominator we have more than one term, so that's what we want t to be. So I'm gonna let 1 plus cosine of x equals u. Then we get minus sine x dx is du. So again, we're gonna have a minus sign, and I'm gonna push that minus sign directly out of the integral and write it as du, and we, of course, in the denominator we'll have a u squared. That's a minus u to the minus 2nd power du. Now we're going to use the power rule, which will be add 1 to the power and divide by new power plus c. That minus and this minus cancel. We just have a 1 over u, and we're going to replace u with what we took u to be, and add a plus c, of course. And that is the answer. Alrighty. Um, all right, for the next question, it's question number 32. All right, this is the first non-direct question that we will encounter today. And all right, so here we see that the derivative of cot x is minus cos x square x. We don't see that anywhere in the integral. So it's not going to be a direct use up, guys. So what we're going to have to do is, whenever you see cot or tan, if you can't figure out anything, just convert it to sine and cos. And I promise you, it will be easier. All right. So I'm going to convert this to sine and this question you will have to memorize a bit because it has a specific approach that you need to know to solve. All right. And now I'm just going to distribute this sine and cos to each term by taking the LCM first of all, and then um, throwing the denominator of the denominator in the numerator. That's what it turns out to be. And of course, we can take this sine x in the numerator. So it becomes sine of x over sine of x plus cosine of x dx. Now we see that we still can't really make a u sub because if we differentiate sine x plus cos x, that'll give us cos x minus sine x, which we don't have in the numerator. So what we're gonna do is we're gonna use a bit of trickery, and this does feel a bit forced, but we're gonna have to do it. First of all, what we're gonna do is we're gonna multiply and divide by 2, and you'll see why in a second. So I'm gonna divide by 2 outside the integral and multiply inside the integral. And you have to memorize this kind of stuff because otherwise it's just not gonna work in the exam. And alright, now in the numerator, we're gonna add and subtract a cosine x for no reason at all, seemingly. We're just gonna add a 0 because obviously plus cosine x minus cosine x is a 0. But we're gonna do that so that our integral is easily solvable. And we're gonna write 2 sine x as sine x plus sine x. Okay, so I wrote one of the sine x here. Then I'm gonna write plus cosine x. And then I'm gonna write the other sine x. and then a negative cosine x. And this is with respect to x, of course, and in the denominator we'll have a sine. In the denominator we'll still have a sine x plus cosine x. Now I'm just gonna move it to the left so that we have more space. And now we're gonna split the fraction. So we're gonna take these two terms with the denominator first and then these two terms, right? So 1 by 2 of course goes to both of them. We still have to integrate. So we have sine x plus cosine x over sine x plus cosine x dx, and then a plus, a half, and then the integral from sine x minus cosine x dx over sine x plus cosine x. Now this just cancels out to be 1. So we just have the integral of 1 with respect to x, so that's going to be x. I'm just going to write this as x over 2 as the x gets multiplied with the 1 over 2. And here we're going to do a u sub, because now if you see, if we let sine x plus cosine x equals t, and we have cosine x minus sine x is equal to dx is equal to dt. And this, if we take a minus sign outside, that gives us sine x minus cosine x dx is dt. And now, of course, we have an extra minus, but we're just going to throw that outside the integral. So this plus becomes a minus, and we are integrating dt over t. All right. And now I'm just gonna integrate. So I'm gonna integrate the second integral in the t world. So that's gonna be a log t, a minus half log mod t plus c. And now I'm just gonna replace what we with t, and that becomes sine x plus cosine x plus c. And that is the answer. Um, yeah, all right. So now the 33rd question is almost the exact same. And all right. So for the 33rd question, you're just gonna wanna repeat what we did in this question, but for tan instead of cot. The 33rd question reads 1 over 1 minus tan x dx. And again, we're gonna do the exact same approach. So we're gonna convert it to sine and cos. And this time I'm gonna write it directly. So this will get multiplied here to give the common denominator of cosine x, and then this gets thrown to the numerator. So I'm just gonna write it directly. Numerator becomes cosine of x, and the denominator becomes cosine of x minus sine of x dx. Again, we're gonna multiply and divide by 2 like we did, and this time I'm just gonna write it as cosine x plus cosine x, because of course this becomes a 2 cosine x, and then we can write this as cosine x plus cosine x. Just gonna copy down the bottom just to not skip too many steps. And now we're gonna add and subtract a sine x. Cosine x plus sine x plus cosine x minus sine x. So effectively, we just added a 0 to make our integral easier. Now we're gonna split the fraction again. This 1 by 2 goes to each of those. So the first it's gonna be this part, and the second is gonna be this part. All right. Cosine of x plus sine of x dx, cosine of x minus sine of x. Then a plus, a half, and then that's just gonna turn out to be 1, but I'm gonna write it anyway for your convenience, of course. Alright, that cancels out to be 1. And for this, um, you have to take this as u. So I'm just gonna write it on the left hand side. Cosine of x minus sine of x is u. We have minus sine of x minus cosine of x dx is du. I'm gonna take the minus sign common outside. We get sine x plus cos x dx is du. I'm just gonna make this replacements now. This becomes a minus half because of this minus right here, which gets kicked out. Numerator becomes a du. The denominator becomes a u, of course, and that's just gonna be the integral of 1 with respect to x. So taking the standard 1 over u integral, that's gonna be log of mod u plus c, and that's just gonna be a half times an x. And we already added the c here, so I'm not gonna write it again. Now replacing, and u becomes, of course, cosine x minus sine x plus x over 2 plus c. That seems to be the right answer. Yeah. Alright, guys, that was question number 33. So now we're gonna do question 34. Right. Question, I believe question 34 is the question you need to think for the most in this whole exercise. So just pay attention, alright? This is gonna be slightly confusing, maybe, but I'm gonna make it as clear as I can for you. Alright, so we have this question. And here, if you see, none of our usual substitution techniques seem to work because, well, there's no derivative for us to take, right? But what we're gonna do is we're gonna just, you have to memorize this kind of. We're gonna multiply and divide in the denominator by cosine of x. So this was the question, and now we're gonna multiply and divide in the denominator by cosine of x. So what this does is I'm gonna pair the division. So we're just multiplying by 1, so it doesn't really make a difference. I'm gonna pair the 1 in the denominator of the denominator with the sign. So the numerator remains the same for now. And the denominator becomes, well, because this goes there, that becomes tangent x, and these two I'm gonna multiply, that becomes cos square x. And now I'm just gonna write um, well, see, I'm so sorry. If we see here, the tan in the above in the numerator becomes tan x to the power 1 by 2, and in the denominator it's tan x to the power 1. So by laws of exponents, we're going to subtract these powers, and then in the numerator it will be, well, half minus 1, so that's just negative half. That's what I have written here in that step. And then I'm just gonna take the cosine square x in the numerator as a sec square x, since those are reciprocals. And now hopefully you can see what I'm meaning to do. So I'm just gonna take, now we can make a u substitution. So let tangent of x equal t, and that gives us sec square x dx is dt, which is here, and that is of course t. So that's just t to the negative half power times dt. Now we're going to use the power rule. So increase the power by 1, that becomes half, and then divide by the new power. So that's just, well, that, add a plus c, and now we're going to replace t with what we took t to be. because, well, you can write this step if you'd like, but it's not really necessary. That becomes that. That is the answer. So if as long as you remember to multiply and divide in the denominator by cosine of x, and then pair it up according to how I've done it, you'll know how to do this question. Then it's simple. But you really do have to remember this, otherwise you won't be able to do the question. All right. Now for the 35th question. It's gonna seem pretty straightforward after the last question because, well, you'll see. So 1 plus log x whole squared over x. I'm just gonna take what's inside the power, so this part, as u. So 1 plus log x equals u, and that gives us 1 over x times dx is equal to du, which we do have in the question because, well, that and that. And this, of course, is a u. So that just becomes u squared du. And now, of course, we're gonna use the power rule. So that's just u cubed over 3 plus c. And we're gonna replace u. That's just 1 plus natural log of x cubed over 3. And then a plus c. That's the answer. Right. Now for the 36th question. The 36th question reads, we have to integrate x plus 1, x plus log of x squared over x with respect to dx. So here, usually we take what's inside the power to be u. So let's just try that in this question. So we're gonna let x plus log x, or this part, to be t. Now we're going to differentiate both sides with respect to x. That's just going to give us 1. That's 1 over x dx is dt. And now we're going to take the LCM here. X plus 1 over x dx is dt. To simplify it simply. And now we see that we do have this in the question actually. So that's pretty nice. This, that, and this, of course, become dt. And this becomes t. So that's just going to give us t dt. And now we're going to use the power rule. So t squared over 2 plus c. Now we're going to replace 2 with what we t with what we took t to be. So x plus log x whole squared over 2 and then a plus c. And that is the answer, ladies and gentlemen. All right. Oh, I'm so sorry. I used the power rule incorrectly because that's going to be a t squared and that will be a t cubed and that will be a 3. Because I'm so sorry for that because in the question it was already a square. That becomes a t squared here, and then of course with the power rule it's gonna increase the power by 1 and divide by the new power, so x plus log x whole cubed over 3 plus c. So sorry for that. All right. 37th question. It's the integral from x cubed sine tangent inverse of x to the 4th power with respect to x. So we're gonna take the argument as the new variable, of course, in this, because, well, that seems obvious. So if I take tangent inverse to the of x to the 4th power as t, that gives us, well, with respect to tangent x to the power 4, it's gonna give us 1, and it's usually x squared, right? But x in this case is x to the power 4. It's going to give us x to the power 4 squared, and then of course with the chain rule we're going to multiply with the derivative of the inside. That's going to give us 4x cubed dx is dt. So what we get is 4x cubed upon 1 plus x to the power 8 dx is dt. And we have an x cube here, we have a dx, And we do have a 1 plus x to the eighth power in the denominator, my bad. So what we need is a 4, right? So I'm just going to move the 4 to the other side. So x cubed over 1 plus x to the power 8 dx is dt by 4. And now, well, this, and this becomes a dt over 4, and this, of course, becomes t. So what we're going to get is sine of t dt over 4. I'm just going to take the 4 outside and integrate with respect to sine t dt. That's going to give me negative cosine t plus c. Now I'm just going to replace t with what we took t to be. So that's going to be, and I'm going to take this negative outside. So minus 1 over 4 of cosine tangent inverse x to the power 4, because that's what t was. And then a plus c. That is the answer. All right. Final two MCQs. Question number 38. And question number 38, it's an MCQ and it looks really complicated at first. But if you think about it, it's really not that complicated, as I'm gonna show you right now. It's 10 to the x. So actually this is a case of direct u sub, because we know that the derivative of 10 x to the power 10 is just 10 x to the power 9, and for 10 over x we can verify it using differentiation, but we know that the uh, derivative of a to the x is of course um, a to the x times log of a. And that's what we have here, right? So I'm gonna just take that the denominator to be u, and now we're gonna differentiate with respect to both sides. That's gonna give us 10 x to the power 9 plus, well, a here is 10, so a to the x is 10 to the x plus log of a. That just gives us, sorry, times log of a, so that just gives us log of 10 dx is du, and we have that in the numerator exactly. So I'm just going to take du in the numerator because all of that becomes du, and in the denominator we have u. That's just a standard integral then. That's going to be log of mod u plus c, and log of mod u is log of x to the power 10 plus 10 to the power x plus c. And that corresponds with option D. And so D part is the answer. All right. For question number 39, the last and final question of this exercise. It is dx over sine squared x cosine squared x. So this is actually a way to write 1 over sine squared x cosine squared x dx. And now what we're gonna do is we're gonna write everything in terms of sine and cos, because, well, we have sine and cos in the denominator. So in terms of sine and cos, we can write this 1 in the numerator as sine squared x plus cos squared x. This is the very first trig identity that we learned, and it's coming in useful now. The denominator remains the same. And now we're gonna split the integral, of course. So it's gonna be sine squared x over sine squared x cosine squared x with respect to x plus the integral of cosine squared x over sine squared x cosine squared x respect to x. And now, well, that and that cancel out, so it's just 1 over cosine squared x, and that cancel out, so it's just 1 over sine squared x. So using the reciprocals, we can write this as sec square x dx plus cos x square x dx. Now it's just integrals we know because the integral of sec square x is tan x and the integral of cosec square x is negative cot x, of course, and then a plus c. And matching up with their answer choices, that matches up with option B. That is our answer. All right. So, guys, that's enough for 7.2. And thank you for watching till the very end. And yeah, I'm going to see you shortly with 7.3.